All attendees are in listen-only mode.
Good evening, everybody. Welcome to another episode of the vBrownbag US. This evening, we are lucky to have Brian Graf for an episode of the DRS Doctor. A little bit of housekeeping real quick before we get the party started. VM Underground opening acts. Find out more about it on vmunderground.com. As always, you can check us out at vmwareprofessional.com. Get in on the conversation either through the Q&A panel for the people that are listening live or through the Twitter hashtag vBrownbag. I'll be monitoring and answering and funneling questions to the DRS Doctor as we go. And of course, Brian Graf is presenting. My name is Chris, and away we go.
Great.
Kick it over to you, Brian.
Perfect.
Press enter. And yes, I am sure.
Great. All right, let's see here. Make sure I pick the right screen here.
I see it. vBrownbag DRS Doctor.
Perfect. All right, guys, thank you for attending, and I'm excited to be presenting here on DRS Doctor. I was kind of voluntold to do this. Which is good because I've been off and on with vBrownbag for about 3 years as far as watching live or watching some of the recorded sessions. So I guess it's about my turn to take a stab at being the presenter. Just real quick about me, for those of you that don't know me, like Chris said, my name's Brian Graf. I work at VMware as a Senior Product Manager for the Distributed Resource Management features. So there's a lot of sub-features in there, but the main features that I work on are DRS, HA, DPM, and then everything else that's included in there, so resource pools, maintenance mode, and a number of other things that we're working on for future versions of vSphere. I live out here in Utah. I love the mountains. I've been out here most of my life. I can't escape all the outdoor activities. So I love to golf, fly, spend time with my family when I'm not working. So what we'll walk through today is we'll just kind of do a quick overview of DRS Doctor. Then we'll jump in to actually talk about a few things around DRS, right? Because DRS Doctor is there to help us understand DRS. So let's get a few things straight about how DRS works, and then we'll jump back into DRS Doctor and we'll go through pretty much everything there. So I've got a couple environments set up. I may be jumping back and forth between the lab and the presentation as we go. So what is DRS Doctor? So DRS Doctor is a VMware fling, and for those of you that don't know what a VMware fling is, it's generally an engineer, developer at VMware, or just I guess anyone actually can come up with an idea and they think it's cool and they think it may be helpful, and so they build it either by themselves or with a small team, and then they post it on the VMware Fling site. And all the VMware Flings are unsupported, but generally they have some good benefits. So DRS Doctor is one of those flings. It's unsupported. You can grab it, you can use it, but if you try and open a ticket or an issue with GSS, they will not take it. One of the great things about these, though, is as you guys in the community use these, try them out, and give us feedback, we're able to better understand, hey, is this something that we should invest in putting into the product, right? And we've seen several flings go from flings to actually being implemented into or integrated into some of the VMware products. So that's kind of cool. Besides that, DRS Doctor is a command line tool. You can use it on whatever operating system you prefer. We have seen that there's a bug doing this on Mac OS, so Linux and Windows are probably preferred. And what it will do is it will record data about DRS and what DRS is doing. One of the big challenges that some of our customers have is that DRS is kind of like a black box. It does what it does what it's supposed to, but at the end of the day, sometimes people sit back scratching their heads going, well, why did DRS decide to move these virtual machines, or why did DRS not move other virtual machines? So DRS Doctor goes in and it will actually create logs and give a better readout of why DRS is doing what it's doing, and some additional information that we'll talk about here in just a few minutes. And then this is all, like I said, it's all outputted into an easy-to-read log, or logs. So one's generated every 5 minutes. They can really add up. We'll talk about that too. But the other ways that we can do this are DRS will create what's called a DRM dump, and that resides in a folder on a Windows vCenter. But if you're using the VCSA, you actually have to generate your VC log bundles to be able to get that, and you have to go in and decipher that. And generally in the past, it usually takes a VMware engineer to look through these and run through them to decipher what's going on. So none of that is ideal, and that's where DRS Doctor comes in. And it wouldn't be good of me to continue on without talking about the three folks that created this. So we have three of our engineers over in India, Adarsh, Sai, and Vikas, and they got together and they created this, and they've done a great job. So shout out to them. All right, so let's talk a little bit about vSphere DRS. Right? So in a perfect world, every vCPU, every virtual machine would have its own direct access to a physical CPU, right? In this type of environment, or in this type of world here, there's never any ready states because there's always a physical CPU to execute the thread for the virtual machine. But as we all know, we don't live in the perfect world, and other times we try to increase or get as much out of our resources as we can, and so we see something like this, which is more of a real-world situation, if you could try to visualize it, which is oversubscribing, overcommitting. This is like about a 4-to-1 ratio. So as you can tell, virtual machines, the vCPUs, may be using threads from other physical processors or cores within the host. So if we take the simplified illustration of the oversubscription and how it leads to contention, you can see that the virtual machines on the left, the ones with the purple and yellow lines, each have their own threads that they're able to execute on. But the other VMs over to the right are sharing some of the same CPUs. Now, luckily, most of the time the CPUs or the virtual machines are not always executing every second, right? And so there's times where the threads are open and that they can switch off between different VMs. And we have a scheduler as well within the hypervisor that allows us to do that. But if you look here, in this scenario, if they were all running 100% of the time, the processors with the red lines underneath them would have contention. Right? They'd be having issues. So DRS comes in for a number of different reasons, not just CPU. We'll talk about memory in a minute. And it does policy-based workload management, right? So what do I mean by that? We have resource policies, we have entitlements, we have resource pools, and we have limit, shares, and reservations. And anyone that's done their VCP on or works in larger environments has probably had to deal with limits and shares and reservations at some point in time in their environments. DRS also does affinity rules and anti-affinity rules. So these are called DRS groups or DRS rules, and they will allow virtual machines to either stay together on a host or split virtual machines between hosts, or even make sure that a VM stays within a group of ESX hosts. From an automation standpoint, DRS is used for load balancing. Essentially, this is what we like to call entitlement-based resource allocation. And what that is it just says, do the virtual machines that are running on these hosts have the resources that they need to execute correctly? Do they have all the resources that they need to, we like to say, to be happy, right? VM happiness. And then it also does a cost-benefit analysis every time that DRS runs. And we'll talk a little bit about that as well, because that plays into how DRS makes the decisions that it makes, and will help you guys understand better kind of what's going on within DRS. And then we have what we call initial placement. Internally, we tend to call it initial placement. I know some places outside we also use that term, but that's essentially when you're powering on a virtual machine or you're creating a new virtual machine, where is it being placed? So if you've got DRS enabled on a cluster and you go to deploy a new virtual machine, you don't have to select a host, right? You can select the cluster and DRS will place it on a host. And that's not done just at random. There's calculations and algorithms that choose the best location for that. And then the other big thing for DRS is around host evacuation. So rolling upgrades with VUM or maintenance mode, DRS handles the redistribution of virtual machines during those rollouts and when those hosts come back online. Okay, so now that we understand a little bit about what DRS does, let's talk a little bit about some of the metrics that are used, right? And I've tried working with engineering to say, hey, can you guys kind of give me a cheat sheet that I can use with customers? But as with any algorithm, right, it gets to be really complex. We have a number of different stats and metrics that are always used when we're doing initial placement and load balancing. But a few of the important VMs that we VM metrics that we tend to use have to do with the CPU active, the run, and the peak. So the active being the amount of activity that the virtual CPU uses over a given time frame. You've got your runtime, and then the peaks, right? What's the max? What did it get to over a specific amount of time? You've got your memory overhead. You've got how fast that's increasing. And then active, consumed, and idle memory. We'll talk a lot about that because this is probably one of the key areas where people get confused about DRS and how it works and why sometimes they wonder why it seems like DRS is not balancing their clusters correctly. And then we have other things like shared memory pages, ballooning, swapping. Hopefully no one ever has swapping going on, but it does happen sometimes. But at the end of the day, the biggest metric or resource that it will use is making sure that the VMs are receiving the resources that they need, right? DRS will not do vMotions or rebalancing workloads if everything already has the resources that it needs. Do you have any questions there?
Yeah, actually, two questions from Graham. The first one is, are there any plans to make the rules more cluster or site aware? Excuse me, aware?
Yeah, so that's actually a great thing that you bring up. I can't really talk about it, but it's good to hear. We've definitely heard people express interest in there being site awareness, especially when you're talking about stretched clusters or when you're talking about hyper-converged. We are looking at a lot of different use cases right now, and that is definitely on our roadmap. But it's something that we need to continue to work with a little bit more and fine-tune.
Yeah, it sounds like metro clusters is the use case that he's talking about. The other question that he had was, in DRS, when you don't have any guests with a reservation, DRS gives a default share of 0. Hold on. Why does DRS give a default share of 0 when the guest doesn't have a reservation? I think I got that right way around. So that when you tell DRS to leave a 50% capacity buffer, it doesn't work as expected.
I'm not quite sure I completely understand that. So there is a default reservation for each virtual machine for both CPU and memory, and I can't remember what it is off the top of my head, but it's small. It's like 56 megahertz. Or something like that.
Right.
But as far as shares go, shares are never an issue unless there's a lot of resource contention, right? So shares are not looked at unless everything is under a high load, and then they have to come in, and DRS has to actually determine which VMs are going to receive priority over others. Okay. So I'm sorry I don't have the answer. Maybe we could talk offline and I could understand the question a little better.
Okay, sure.
All right. All right, so going on. So during initial placement, like I said, one of the biggest things that happens is the algorithms that go into effect, they say, you know, how can I ensure that there's the least amount of performance impact on the virtual machines that are already running? Okay, and then during load balance, we say, how can we ensure that there's the least amount of impact on both the source and destination hosts if I'm moving virtual machines around, right? And we'll talk about that a little bit too, around how vMotions have impacts. Load balancing will always have some form of an impact because of what we're doing, right? DRS tries to have the least amount of impact there. So this is an area that I kind of want to focus on really quickly. I'll just kind of bring all these up. There are certain constraints, and I think it's good that we talk about this, especially for those people that are working on their VCAP exams or working towards their the vCenter Advanced Professional certifications, understanding some of the constraints of DRS. So affinity rules and anti-affinity rules, although some people really like to use them, every time you create an affinity rule or an anti-affinity rule, you're creating a constraint that DRS has to work around. Right? So if you're creating rules about where virtual machines can and cannot be placed or which other virtual machines they cannot be paired with, depending on how overboard you may go with these DRS rules, you can make it really hard for DRS to balance out the cluster properly. And part of that depends on the number of virtual machines and the number of hosts, but just keep that in mind as you're working on it. Number of concurrent vMotions, and the time to complete vMotions, these are all taken into account. So obviously using a 10 gig network for vMotions is going to make things a lot easier. You can have more concurrent vMotions, they complete faster, they have less of a cost on your environment. And DRS will take those numbers and it understands what the speed of the network is for the vMotion traffic, and it will compute that and use that accordingly. But you can see that you know, a vMotion over a 1 gig link may have a higher cost than a vMotion over a 10 gig link. vCPU and pCPU ratios, they also can be a constraint if you're using advanced options as well. This can create specific constraints, but overall, you know, this is a big part of the decision making. So as you're looking at how you're operating your environment, let's say day 2 operations, right? You need to be aware that the things that you're doing in your environment can have an impact on how well DRS can work. So the cost of a virtual machine is just weighed, and we do this kind of a what-if scenario. And we go through every time that DRS runs every 5 minutes, it goes through the algorithm, and it says, all right, you know, is this host a good fit for virtual machine X, right? And part of what's considered, as you can see here, is that when you're doing a vMotion, there's definitely a small to large CPU hit, depending on what type of host you're using. 1 gig network for vMotions will use 30% of the CPU core, and then 100% of a CPU core for 10 gig vMotion. And there will also be memory consumed on both the source and the destination virtual machine as it's performing the vMotion during the DRS rebalances. So there's a few things to consider here and to understand as it's going through and determining the best place for virtual machines. So I want to take a quick minute and talk about memory and why this is so important. DRS uses active memory when it's making its decisions for the DRS load balancing. Okay, and active memory is, like it says on the screen, it's going through and it does a calculation over recently touched pages, and it will sample a certain amount and see if they're active or if they're hot. And depending on the amount of active memory plus a buffer, which you'll see here in just a second, 25% buffer is what DRS uses by default to calculate memory usage for virtual machines. And this is important to understand because if you look at the UI, and this is where people get really confused, is as you can see here, I've got 4 hosts, and my consumed memory percentages are all over the place. And customers will look at this and go, look, DRS isn't doing what it's supposed to. And when in fact, it's not basing itself off of consumed memory, right? It's basing it off of active memory. Now this is something that, that I've taken on since I've started here, and we're going to change this with the UI to make sure that we can start showing as well active memory or another metric here that will make it easier for the customers to understand that things are being load balanced. Okay? The consumed memory is not a good indicator generally, because you can give a virtual machine, for example, a Windows machine. Let's say that an admin gives it 32 gigs of RAM. It's possible that when you power on Windows that it consumes potentially all of it or almost all of that memory, but the active memory may be less than a gig. Okay? From an admin's point of view, you see that 32 gigs is being consumed. From a overcommit, from a virtualization perspective, only 1 gig of that's actually being used, and you shouldn't be balancing based off of the inactive memory, right? It's memory that's been grabbed, but it's not actively being touched, it's not being leveraged. Linux is a little bit better because generally Linux doesn't go in and just grab all the memory when you power it on. It uses it as it needs to, but it's just something to be aware of. So when your environment says you're at 90% utilization for consumed memory, and you're wondering why DRS hasn't pushed some of the virtual machines from that one to a host that's at 50% consumed memory, it's because it's balanced on active and the actives are roughly the same. Okay? So if you go into the monitoring tab for a cluster and you click on the vSphere DRS tab, you see here it's just another place where you can see this graph of consumed memory. So as you see this, it looks like it could be balanced out okay, and that's mostly because I'm running all the same workloads across all the different hosts here. But you'd have to look at the performance charts or ESXtop to see the active memory. So what I'm showing here is on the right-hand side, when you go into your performance charts for a cluster, you can see that I've got the granted and the active memory. So the granted is pretty much just memory that's mapped to the machine memory. It includes shared memory, but it doesn't include any sort of overhead, which is usually pretty small. But as you can see here, my active memory at one point, right between 320 and 330, becomes right about the same as the granted. And at that point, DRS kicked in, and it actually, we'll look at some of the logs, but it actually took place, it's been doing vMotions and load balancing throughout these time periods. Now, if you're doing DRS and you're not running it in fully automated mode, well, actually, if you are running it in fully automated mode, you won't see these recommendations. Okay? In fully automated mode, DRS will just go out and do what it needs to do. If you have DRS set up in manual mode, you have to see these recommendations and you have to apply the recommendations every time. That could mean checking in on this every 5 minutes. It could mean that you just don't take the recommendations for a certain number of hours. But if you turn it to manual and you let DRS run, you'll get a small sense of kind of what's going on with DRS. So you'll see here that there are 4 recommendations and there's priorities. So those priorities are mapped to the migration threshold, choosing how sensitive DRS is. So the priority 5 is a virtual machine that wouldn't move unless you had the setting at migration threshold 5. 3 is the default, and so you can see that there's a number of if you had this set to migration threshold 5, 5, 4, 3, and 2, any of those priorities would be recommended and applied if this were in fully automated mode. We're going to go in and use DRS Doctor to see pretty much the same types of reasons that we have here, but we'll also see the entitlements. So with that, let's jump over to use DRS Doctor. So there are some requirements for DRS Doctor, and you'll see them here on the Fling site. The 2 big things are that it requires Python 2.7.6 or higher, and then a few Python modules. Okay, and there's instructions on where to get those and how to get those. I'm going to go ahead and move my workstation stuff up. But
Quick question.
to just, yeah.
Does it work in Python 3?
Yes, it would, because
Okay.
it's 2.7.6 or higher.
Gotcha.
So yeah, great question. So there are a number of steps that you have to take, and Matt Meyer, who's the technical marketing manager that wrote up the how-to for this, actually if I go back to the DRS Doctor page, has instructions here that you can download this PDF on how to install this on CentOS. James Green from the community also did this on Windows, and then I'm going to show here tonight how I did this on Photon, VMware's open source OS, and I'm going to write up a blog post hopefully tonight or tomorrow morning with the steps and with the script for this to be used by anyone. So you'll go ahead and see all the different packages that get installed, which is why I prefer to do this in an automated fashion. So just using this, I have a recently deployed Photon OS virtual machine, and I've typed in this one command here to go and get a install file from my Dropbox, and we'll grab that really fast, hopefully. So once we've grabbed that and we download it to our local machine, please work. It normally does not take this long. We'll give it another 30 seconds or so, and if it doesn't work, then I will just show you a video of how this works. Because I did a complete install start to finish in 90 seconds, which is another reason why I like Photon. All right, well shoot, we'll go to the movie. That's why I like to have backups. All right, so this is DRS Doctor on Photon. So you'll see up here at the top that I start out, I have just grabbed that file with wget. I go ahead and change the file to an executable that you can see there, and I run the shell script. And it will go ahead and it will start to install the packages that I need for DRS Doctor. And as you can see, it's kind of nice to have this automated here. It'll download and install the Perl packages that it requires. And then once this part is done, it will automatically kick you into the configuration file for DRS Doctor that you need to set up to point to your vCenter and the cluster that you want to manage. So we'll see that here in just a second. All right, so in here we have our configuration file, and you'll just need to edit the VCIP, the VC user, and the cluster. So here I put in the IP address for my vCenter server. I go ahead and put in the password. I'm just using the default administrator password, and I put in the cluster that I want to monitor. If I save this, I can then run DRS Doctor. Once I go to the correct folder, and it will ask me for my password. So I'll go ahead and put in the password associated with the username, and it will start generating reports. So this log is the first that will be created every 5 minutes. All right? So easy enough, especially with the install script. You can be up and running in about 90 seconds. But how does DRS Doctor work? So this is something to keep in mind, especially because, like I said, it's a fling and it's not supported. DRS Doctor will place the cluster that you choose into partially automated mode. So if you've got it set in fully automated mode, when DRS Doctor turns on, like we just did here at the very end, it will kick it down into partially automated mode, but it will act on every recommendation immediately as if it were in fully automated mode. And this is just something that the fling has to do to be able to grab the information for the log files. So we're hoping to change that up in the future to be able to do this as well, straight from the fully automated mode. But the one thing to remember is when you're done using DRS Doctor, you need to go ahead and go back into your cluster and change that to fully automated mode. So we'll go ahead and close out of this one. But let's say that you've run DRS Doctor for a while. And you want to see what things look like. So I've got a few different VMs up, and this one here, you can see I've got a lot of log files every 5 minutes for about a day and a half. So instead of having to go through each one of these log files, which we can definitely take a look at some of these. I'll jump over to the UI version of the CentOS to look at individual ones. I'll show you that we have this log parser that will go ahead and wrap all these up for us. Before we do that, I'll come over here to this CentOS machine, and we'll go into the DRS Doctor folder, and we'll see this folder called Logs. So in here, we have our logs like we had before, and then we created summary, entitlement, and audit logs. And what this does is it just parses out all the data from all the different logs that you have in the folder and places the relevant information into each of these logs. Chris, any questions?
One quick one. Can you monitor multiple clusters, or do you need a separate Linux machine?
Fantastic question. You can do multiple clusters. You just need to have a different, you need to have another instance of DRS Doctor running. So in this case, I could create multiple folders and just toss in the DRS Doctor files into each folder and just change the config to point to a different cluster each time.
Gotcha.
We're hoping to change that in another version, but currently it's just one cluster at a time. All right, so let's go ahead and open one of these. This one, we'll see what we have in here. So this is what a DRS Doctor log will look like. What we have here is a beginning summary. So one of the big issues that people have is that they don't always know what the advanced options are that are running in that cluster. They don't know what the DRS rules are that are running in that cluster. And so if there are any affinity or anti-affinity rules, it will output those in each of the log files. So it's a really easy and quick way for someone to go in and see what is running in this, what are my advanced options set at, without having to go into the UI and dig through that. It then also shows the cluster balance. So you can see here that my current balance is 259 and the target balance is 35. Obviously it's imbalanced, and this is because I put everything around. I ran a bunch of stress tests on a bunch of virtual machines. I used PowerCLI to kick these off on 20 different VMs on the 4 hosts and let them run. Underneath the summary, we can see different tasks that we're running. So you can see here that we had an apply recommendation for the cluster at a specific time. And then the recommendations here we'll see again, but this is a rating 4 or threshold 4, and it says we should migrate VM17 from host 2 to host 1 at a specific time, so we can use that as part of our logging. And the reason here is fairness CPU average. Okay, now that doesn't come out and say exactly why DRS did this, but it gives us a better understanding. Obviously there was some sort of CPU contention at that time. We'll jump down a little bit further on to see a little bit more about this. So remember VM17. We also have applying recommendations for VM18 and then a few other tasks running inside as well. If we scroll down a little bit more, we should be able to get to, looks like we had a little bit of an error here, to the entitlements. So we can see the virtual machines with their VM IDs, the VM name, and then we can see a lot of the entitlements that DRS looks at. Now granted, this isn't all the entitlements or all the metrics that DRS uses, but it gives us a better understanding of what's going on here. In this instance, VM TMPL has an entitlement of 15 megahertz which is nothing, right? The demand is 23, and the used is 40. Okay. We can dig into these and talk about these a little bit more. There's a great blog post on the vSphere, blogs.vmware.com/vSphere, on how to use this and on what everything here means. But this is, as you can see, a really easy way for us to look and say, okay, at this time, what is that, 5:16 p.m., I was able to see the entitlement and the resources being used by each of my virtual machines in this cluster. Above each one, it will show you kind of an overall host utilization as well. So from a host level, you can see what the CPU capacities are and entitlements are, and the percentage used of both CPU and memory for that host. If I scroll down to the bottom, you'll see after those 4 hosts, you'll see I've got 4 other hosts here that don't have any VMs on them. That's because these hosts are in maintenance mode. I took them out so it would be easier to show on fewer hosts. But as you can see, it gives you a complete encapsulation, quick overview of what's going on in your environment. Okay. After that, there's an audit. And this is something that people have been asking for a long time. So if this is something you find useful or interesting, please comment on the blog. Please comment on Twitter, in the VMware forums. If this is something that you feel is useful, that's the type of feedback that we can use to better the product in future releases. What this does is it says, tell me everything that occurred in the last 5 minutes, right? So VMs migrated is saying, all right, there were 7 vMotions that occurred in this cluster. As you can see, that DRS recommended all 7 of those, so those were all done by DRS. And VMs placed would be power-ons or new virtual machines or user-initiated vMotions. So at any given time, you can go back through and see why things moved and when and which virtual machines they were. So as you can see here, in this time, all of these were getting hammered from a CPU perspective. The fairness CPU average is what was used to kind of load balance this out. All right. How are we doing on questions, Chris? Do we have any more?
One quick question. Can it run from initd as a service?
I have not tried. I wouldn't put anything else on those machines. It's not difficult. Like in this example, Photon OS is only like 200 megs and 1 vCPU,
Gotcha.
and it's free. So I would recommend doing it on a separate virtual machine.
Okay. And one other comment would be cool if that could also export the logging to your central syslog server.
That would also be good. That's a great comment. It's something where I was hoping to try to set this up with like Log Insight before this this webinar, but I just didn't have enough time. But yeah, definitely being able to take this and audit it. What would be even greater, in my opinion, right, is if DRS would just do this automatically, and that's something that we're looking at, and hopefully you guys can give your feedback on this as well.
Definitely.
Okay, so now that we've looked at one log file, that's 5 minutes, and I have a day and a half's worth of logs to go through. So how am I going to do that? Well, we added in an additional shell script called log parser. Here I am in the DRS Doctor folder, and if we just take a quick look, the parser script is in the logs folder. So if we just go into our logs, you can see that I've got, oh, you know, this is not the one that has all of the logs. Here we go. We'll just do it from this one here. So if I run log parser, what it's going to do is it will give me a thing that says no boundary files were specified or files were invalid. And it will just go ahead and do all the log files in this folder. The reason for that saying is that you can go ahead and use additional parameters to specify certain time ranges. So if you don't want to aggregate all of the different logs here for the entire time that you've run this, maybe it's 2 weeks, and then you've got thousands of logs, you can use the log parser shell script with the parameters to specify the dates or the time range that you want to use, and it will output just those ones. And it creates the audit and entitlement and summary logs. So I already had some in here because I ran this before, but let's go ahead and just take a look at the audit log. So as you can see here, I've got a portion of my logs, and this one shows that starting July 26th at 7 p.m., I can see that 12 VMs were migrated by DRS, and I can see why. I can see that these ones were a memory average all the way down into a host and degradation mode. I'm not quite sure what that one is. I'd have to go look that one up. And one at the very bottom for CPU. And we can see which hosts the VMs resided on and which ones they were moved to. And if I Control D down, I can see this for all the different log files for every 5 minutes. So this is much easier to quickly go through and look at your day than having to open up every 5 minutes. And you can see here, I had a number of times where DRS didn't do anything. The reason is that this is my home lab, and I wasn't running the resource stress tests during these times. But if I continue to go down, I'll hit another time that I was doing that. We'll see some more VMs. Oh, there we go. You'll see here that DRS moved 5 virtual machines around because of memory entitlements as well, and then 5 minutes later, it migrated one more for CPU average. Now keep in mind, I have my migration threshold set to 5, which is the most sensitive. It has the least, the smallest standard deviation out of all the different migration threshold settings. So this is going to move around virtual machines even for the slightest gain or benefit for the environment. So if I back out of this one here, this was the audit log. If we go back here and we look at the entitlements, we'll then see for every 5 minutes all the different entitlements for the different hosts and virtual machines for that cluster. So as we saw, you can correlate if there was a vMotion that was done for VM17, and we saw that in the audit log, and we saw that it was around memory fairness, then we could come in here, find that same time, and look and see, well, what were the entitlements? What was the demand, right? Was there any swapping? What was the shared size? Active memory, where were we at, right? And you can dig down through this and quite quickly kind of start to see why DRS is doing what it's doing or why it's not, right? If it's not making enough vMotions or DRS recommendations and you're set to level 2 or level 3, try bumping it up to level 4, right, or level 5, and find that sweet spot where DRS is balancing everything out in a way that is best for your environment. Okay. And finally, we'll go back here and look at the summary log. All right, so if we wanted to quickly see when there were imbalances, when there were balances, and if any advanced options changed at a specific time, maybe somebody put in an advanced option while this was running, you would see that here, and you'd go, hey, okay, somebody put in an advanced option between 7:30 p.m. and 7:40 p.m. Who was logged in, why did they do that? And this is where we start seeing either performance gains or performance issues. This is just an easy, quick way to troubleshoot that, as you can quickly go through all the different timestamps and logs. All right. Any questions?
No, we are good.
Awesome. Well, I will open it up for any other questions. I've pretty much covered everything that I had been planning to cover.
Nice.
I thought maybe we'd have a couple more questions, but hopefully that just means that I did a good job covering everything.
That was very comprehensive. Hold on. Let me check the Twitters and the other areas for questioning.
I will put back out there again though, for anyone that is interested in using this or has any comments or feedback on this. I'll go ahead and put my information back up on the screen at the very end of this, but it's at vBrownbag on Twitter and grafb at vmware.com, and I'm always up for receiving feedback and comments. Those that know me in the community know that I'm always reaching out with either surveys, polls, or just questions for the community. So your comments, your feedback is what shapes our products to some extent, and that's very valuable to me.
Okay, a couple have popped in. Is this applicable to SDRS as well?
This is only for DRS.
Yeah.
Good question.
Any plans for graphs or reports?
Yeah, so that's a great question. So this is all text-based. This is pretty much all CLI-based, and so it has its issues. One of the things that we've talked about doing, and I've talked about with the team that created this, is in an additional version. We don't have a time frame for this yet. Would be to have graphical charts, right?
Right.
Maybe pass this out to a CSV instead of a log file, and then also I think I'll talk with them too about being able to pass this type of thing onto syslog server, because that was a great comment.
Cool. Nope. Okay, so we are clear for questions. If you want to go ahead and put your contact information back up again, I'll give the guys a couple more seconds to feed anything by. Yeah, so
Great.
Outdoorsy and clean shaven. Look at you. Cool.
That's what people think I look like. That's only when I'm out in public. When I work from home, it's a little less clean shaven.
Oh yeah.
But,
well, we all tend to let things go by the wayside. I'm currently very bearded.
I'm not that much, but I think we all tend to let ourselves go a little bit here.
Well, you especially, in a couple of months, you're going to be letting yourself go really far.
That's for sure.
Once you stop, is it going to be your first?
It's baby number 3, so we're starting to get outnumbered if we're by ourselves.
Oh, okay. Well, then you're already used to all the sleep deprivation.
We'll see.
Cool. Okay, so we are definitely good for questions. Twitter is clear. Local questions are clear. Awesome. I'm going to go ahead and stop recording now.